We have been given this figure and we are required to find the radius of this circle. This is a quarter circle, as you can see, where this is the center O of the quarter circle. So we have been given that this side length from this point to this point is equals to from here to here. This is 30 degrees and this side length is 4. And this is 90 degrees. So with that information, how can we find the radius of this quarter circle? First, let me label the points. Let me call this A, this B, C, D, and this E. Since it's a quarter circle, this angle here is 90 degrees. Now focusing on this triangle COD, this one here, since this is 90 degrees, that means this angle and this angle, when you add them, you're going to get 90 degrees. So that when we add all the angles, we get 180. Now, if this and this add to 90 degrees, it implies that they are complementary angles. Okay? Since we have been told that this side length is equals to this side length, this implies that this angle is equal to this angle. Since they share 90 degrees, that means we split the 90 into 2. So this will be 45 degrees. This is also 45 degrees. So we can use this angle and then we use cos. So cos to find OD. So cos of an angle is equals to adjacent over hypotenuse. Okay, so cos of 45 degrees is equals to, the adjacent is OC. We are using this angle 45. So the adjacent is OC over the hypotenuse, which is 4. Therefore, OC is equals to 4 cos of 45 degrees, which is equals to 4 times 1 over root 2, which is equals to 2 root 2. Therefore, OCO is 2 root 2. Now again, focusing on triangle CDE. This one here, which is like this. This is 90 degrees. I'm sorry, my diagram is not to scale. This is 4, this is 30, this is 90 degrees. Since this is 90 degrees, that means this is the hypotenuse, okay? So again, using cos of theta is adjacent over hypotenuse. So cos of 30 degrees will be equals to A. No, this was C, not A. It will be equals to CE over 4. Therefore, CE is equals to 4 cos 30 degrees, which is equals to 4 times root 3. Cos is root 3 over 2. Therefore, CE is equals to, this divides into 2 to get 2 root 3. Therefore, here, this CE is 2 root 3. Now, to find DE, we can use sine, which is SOH from SOHCAHTOA. So, sine theta is equals to opposite over hypotenuse. So sine of 30 degrees is equals to DE over hypotenuse, which is 4. Therefore, DE is equals to 4 sine 30 which is 4 times a half, which is equals to 2. Therefore, DE is 2. Now let's draw a line to join point O to point E. Just like this. Now let us focus on triangle COE. Okay. In triangle COE, we realize that OE is the radius of the circle, of the quarter circle. Okay, which is, let's call it R. And this angle OCE, this whole angle, is equals to 45 degrees plus 30 degrees, which is equals to 75 degrees. And we know that in any triangle of this nature, where this is A, this is B, this is C, this is angle, this angle is theta, this side is A, this side is B, and this side is C, then we can say that cos of theta is equals to A squared plus B squared minus C squared over 2AB. Therefore, going back to our triangle COE, so using this, that implies that cos of 75 degrees will be equals to, our A is 2 root 2, so 2 root 2 squared plus our B is 2 root 3, 2 root 3 squared minus C, which is the radius, which we've called R, so R squared over 2 times A, which is 2 root 2, times B, which is 2 root 3. Therefore, cos 75 degrees is equals to, this here we get 8 plus, this gives us 12 minus R squared over 8 root 2 times root 3, get root 6. So we shall have this multiplies by this to give us 8 root 6 cos of 75 is equals to 8 plus 12 is 20, 20 minus R squared. So we make R squared the subject. So R squared will be equals to 20 minus 8 root 6 cos 75 degrees. So therefore cos, we know that cos of 75 is equals to cos of 45 degrees plus 30 degrees, which is equals to cos of 45 cos 30 minus sine 45 sine 30. This is equals to cos 45 is 1 over root 2 times cos 30 is root 3 over 2 minus, this is a half, 1 over root 2, and then this is a half. So this is equals to root 3 over 2 root 2 minus 1 over 2 root 2. Therefore, cos 75 is equals to root 3 minus 1 over 2 root 2. So going back to our R, therefore R is equals to 20 minus cos of 75, which is this. So minus 8 root 6, then cos of 75, which is root 3 minus 1 over 2 root 2. This 2 cancels out with this 8 to give us 4 here. Therefore, R is equals to 20 minus 4 root 6 into root 3 minus 1 over root 2. Now root 6, so R will be equals to 20 minus 4. Root 6 is the same as root 3 times root 2. So this is into root 3 minus 1 over root 2. So this root 2 cancels out with this root 2. And we have r being equals to 20 minus 4 root 3 into root 3 minus 1. Sorry, this is r squared. I don't know why I've been writing r. So r squared is equals to 20 minus 4 root 3 times root 3. Root 3 times root 3 is 3. Okay? So 3 times 4 is 12. Then minus 4 root 3 times 1 is 4 root 3. So we open the bracket. We shall have r squared is equals to 20 minus 12 plus 4 root 3 because negative times negative. So r squared gives us 20 minus 12 is 8 plus 4 root 3. Now let us find the square root on both sides. So square root here and square root here. This cancels out. This would give us positive or negative, but since r represents length, then it should be positive. So we only take the positive, okay? So r will be equals to root of 8 is the same as 2 plus 6, then plus 4 is the same as 2 times 2, then times root 3. So r is equals to 2 plus 6 plus 2. Okay, we first write 2. 2 is the same as root 2 times root 2. So root 2 times root 2. This goes back to 2. Then times root 3. Okay, so r is equals to square root of 2 is the same as root 2 squared. Then plus 6 is the same as root 6 squared. Then plus 2 root 2. Root 2 times root 3 gives us root 6. We are trying to expand that to get identities, okay? So r is this, and we know that a squared plus b squared is equals to a squared plus 2ab plus b squared. So this is the form that we have. So we can represent it in this way. Therefore, r will be equals to root of square root 2 plus root 6 all squared in this form. Okay? So r is equals to, so this cancels with this. So we have root 2 plus root 6. So this is the value of the radius. You can simplify it further and give the actual values. But this is the value of the radius. Thank you so much for watching. Kindly subscribe to this channel if you haven't done so. Like this video, comment and share your thoughts about it. And also, let's meet in the next video.